Okay, welcome back students. So in this video we're looking at section 20.1. Okay, that is distance time graphs. Okay, so I don't think this one has an example as such except in a green box. However, so we'll just discuss what distance time graphs are. Okay. So, and I'm just going to go straight through the book and we can discuss it. So, a distance time graph or a travel graph is a special type of line graph. Okay, is a special type of a line graph. So there's no curved, well in this case there's no curved areas, we're just joining the dots. The assumption there, by the way, is that the velocity, there's no acceleration, used to describe a journey. So in a distance time graph, as long as there's no acceleration, the slope tells you the speed, and if it's straight across it tells you that the item or the person is stopped, and if it's a positive slope they're going away from you, and if it's a negative slope they're going towards you. And it's a line graph because you join dots as long as there's no acceleration. Okay, as long as you're not speeding up or slowing down, you're just going at a fixed speed and then you suddenly change your speed. So here they're going at a fixed speed, they suddenly stopped, they suddenly started going at another fixed speed. Here they're going at a fixed speed, suddenly stop, suddenly start coming back, and suddenly speed up to a new speed coming back, and so on. Okay, the vertical axis, this one, is distance, and the horizontal axis is time. And in this case it gives you a context. It describes the journey of a cyclist set out from town A. Now in the links below I'll give you some interactives that you can do where it shows cars and motorbikes passing each other out and things like that, and an accident even in an ambulance coming along, and you can look at various scenarios using technology. But we're going to keep it simple here and just work through the book. Okay. Okay, so basically, rather than keep jumping over and back between the pages, we're just going to describe what's happening here, and then we'll go on to the example. So let me just push this out here a bit. Okay, so let's just analyze and interpret what we're looking at here. So let's first of all work out the speed of the cyclist to begin with. So speed is distance over time, which is the slope. So in this case the speed will be, they've traveled 20 kilometers in a time of 1 hour. So their speed, and we need to check the units, their speed is equal to 20 kilometers per hour. Then they stopped for a half an hour, because you can see the scale here is 2, so they stopped for half an hour, and then we'll work out there, and then they went faster than before. You could say, think to yourself, maybe they're trying to catch up from the fact that they had to stop. They could have stopped at a shop or anything. Okay, stop for coffee. Okay, so now what's the story here is we're going to look at the rise, which is how far they traveled, which is 60, take away 20 is 40, so we'll just call it speed 2. 60 take away 20 is 40, and the time period of this is a half. Okay, because it's 2 boxes, which is a half, so we're dividing by a half, or we're dividing by 0.5, so their second speed there was 20 kilometers per hour, 5 times faster. Okay, then they stopped for another half an hour, and their return speed, now you can call these positive speeds, and their return speed, speed 3, was equal to, so it's a negative speed, or it's coming backwards, and we look at the distance is 60, because it's 60 take away 0. Speed equals distance over time, by the way, that's what's going on here, and it's really calculating a slope, and the time it took them to come back there was, very careful here, 2 boxes, a half, so minus 120 kilometers per hour, which would be the speed limit on, well, that couldn't happen, distance kilometers, time per hour. Okay, but this is a very, very fast cyclist, because they're travelling at 120 kilometers per hour, that's a speed limit on a motorway. Wow. Okay, a bit unrealistic, but we'll go with it. And that's what the model tells us. Okay, now other types of question you can be asked, now pay particular attention, is label the sections on the graph X and Y, label them X and Y, where the cyclist was stopped. Okay, and we come along here and say they were stopped there and they were stopped there. Okay. Okay, now what else could we ask? We could say another cyclist we had 20 traveled at plus 30 kilometers per hour for 1 hour, stopped for half an hour, and then returned, arriving back at the same time as first cyclist. Okay, so as long as you understand that, you don't have to worry about how bad my writing is or anything. So another, and you'll be asked to graph it. So we'll just do it here, even though the graph's a little bit small. So I'm trying to get organized, and I hope you're trying to get organized with all your rulers and things like that. So even though before I used to say, oh, put all your stuff in your pencil case, I'm actually turned around and been converted into being a fan of the old metal box or geometry set, because at least you can know you've got everything in there that you need. Maybe have a full length ruler separate, and make sure you have loads of, or at least one, but you should have several pencils, and you sharpen your pencil before an exam. Okay, so we're going to create a 30 kilometers per hour for a half an hour. So the main thing is the half hour, so that creates my vertical line. And then, so I'm going to be at some point on this, I'll be finding they have to travel 30 kilometers, they have to travel 30 kilometers, so they only have to come up, because they're traveled at 30 kilometers. So what we'll do first is we'll say in 1 hour they should be pointing at 30. They should be pointing along this line, but the reality is that only happened as far as here for half an hour. Now let's do that again, because I seem to have got that wrong. In 1 hour they went 30. How can this be? No, 20 to 40 is 30. In half an hour they couldn't go 20. Is there something wrong with my scale? 10, 20, 30. There's 30. There's an hour. Half an hour is here. Am I losing my mind here or something? So that's a half an hour. This is 1 hour. They definitely traveled from there to there. I mean, they definitely would if they kept going, but we know they started after half an hour they were here, but they weren't at 20 after half an hour. (10, 20, 30, 40, 50, 60). 15 minutes, 30 minutes, 45 minutes, 1 hour. Another travel at 30 kilometers per hour for 1 hour. Oh yeah, okay, well, and then they stopped here. Okay, anyway, can't even read my own instructions, but I'm going to leave this up because it's good old problem solving and we're going to keep it. Okay, now they stopped for half an hour, which is 2 boxes. And then returned back at the same time as the first cyclist. So they will arrive back after 3 hours, so they'll be traveling, and you might be asked to find the speed that they returned at. You also might be asked to find for how long, for instance, was the first cyclist more than 50 kilometers from home, and you'll be measuring this. It'll be two boxes, maybe 2.5, 3 boxes, and whatever, and you'd read that off your graph. You'd do your best to figure out this time and this time, and you'd subtract them. Okay, so it just gives you an idea of the type of questions we can be asked. And now we'll just get into answering the questions. Let me just rearrange myself here. We'll get into answering just a few of the questions from the book. Okay, so let's start off with question 1. This travel graph gives the distance of a boy from home. Okay, when did the boy leave home? 9 a.m. How far was he from the home? At 1 p.m. Okay, now the best practice here is to, again, you're using it. The reason you'll be using a pencil, a sharpened pencil, is that you'll be able to change it. And the most important piece of equipment of all is your rubber. Okay, so now you can get away with using pen, but it just means you don't have that ability to revise. So the recommendation is use pencil for any graphing and drawing questions. At what time was, how far was he from home at 1 p.m.? So the idea here is, just to break it down, is to find 1 p.m. on your time axis, go straight up and straight over, and the answer is 30 kilometers. Okay, at what time was he 15 kilometers from home? Now there's a plural on that, okay, for a reason. Okay, now we know if a function you put in one value, you can only get out one value, but the inverse function can have several values, as this one is going to have. So at what times was he 15 kilometers from home? So we start on the vertical axis at 15, we draw a vertical line, we draw a horizontal line off the vertical axis. We find out where it meets the graph and we come straight down. Okay, so that would be 9:45 a.m. and the second one there is at 2 p.m. Okay, and when was he traveling most quickly? Now most quickly doesn't matter whether he's going away from you or towards you. In other words, where's the graph steepest? If you eyeball this, it looks steepest here, but we can double check that this one isn't steeper. Okay, so our rise is 20 and our run is 1. So the speed here is 20 kilometers per hour. We need to be careful here. We know he traveled back 30 kilometers in 2 hours, so here's would have been 15 kilometers per hour, and you might call that negative. Okay, so the answer is, when was he traveling most quickly? Between 9 and 10 a.m. Now, in order to continue with my good practice, we're going to grab the solution list and check how we're doing. I hope we are anyway. Oh yeah, I need to staple this. Chapter in chapter 20. Okay. And we got a red pen. The answers are 9 a.m., 3 p.m., when did he return? I never answered it. 3 p.m., How far was he from home at 1 p.m? I said 30 kilometers. Yes. We got 9:45 and 2 p.m. Yes. When was he traveling most quickly? At what time did he rest? Missed that one, didn't I? Between 10 and 10:30. At what time did he rest? 10 a.m. to 10:30, and from noon. So he rested in both of those times. Okay, we get the idea, and I can see here it's reflecting on this. I need to be a little bit more careful. Okay, let's do question 3, and then I leave it to you to do the rest of them. And yeah, so let's do question 3 now. I'm going to answer straight into the book. The travel graph shows the distance of a cyclist from his home. So if I'm learning anything from my previous performance, it is I must be just more meticulous and careful to answer each section and to interpret the questions more carefully. In other words, to read the question carefully. Okay, again it's a cyclist, but by the way, it can be a helicopter going up and down, not left and right, not going forward, backwards. So just watch out for that. From his home between the times of 10 a.m. and 4:30, correct? Okay, how far does the cyclist travel in the first 2 hours? So let's say we're going to bring this line up here and to see that it's 20 kilometers. 20 kilometers. Okay, how far from home is he when he stops to rest? Same answer, isn't it? Because he stopped to rest here. 20 kilometers. At what time does he commence the return journey? 1 p.m. At 3 p.m. his speed changes. Do we agree? Yes. At 3 p.m. his speed changes. Does it increase or decrease? His speed, now speed is the size of his velocity. So it increases because it gets steeper. It increases. How can you tell without calculating the actual speed? Slope. The slope is steeper. How far does he travel? Ooh, lovely question. So he travels, so we're going to add up the fact that he travels out 20 and he travels back 20. The answer is 40 kilometers. It's taking that value and doubling it. And watch out for that. If it ever goes up, down and up again, then you'll have to increase. It isn't always going to be double that value. Okay, that was a really nice question. I hope this video gets you started. We can do a longer video for the solutions, but do your best to answer them, and we will see you in the next one.